Parasite Management, IPM. I didn't make up this phrase, but I myself like to equate it to crop IPM, integrated crop management, integrated pest management for crops. We used to just spray fields with chemicals to control weeds and pests. And the idea of crop IPM was to send a person out there to scout the field and decide what part of the field needed sprayed and when it reached an economic threshold. So I like to think of integrated parasite management the same way, in the sense that we're going to treat animals when they need it, and we're going to treat the animals that need it. But we're not going to do this thing like we did in the past, which was to regularly treat everyone, to kind of use the dewormers as a preventative, and to forget about all the management practices that we can actually implement that will minimize the need for deworming. And so what I want to talk about tonight is some of the different practices, ideas that you can implement without using the anthelmintics or before using the anthelmintics. Again, anthelmintic is just the fancy term for a dewormer or a drench. And I don't mean to imply that they're not part of integrated parasite management, because they often are. But let's tonight focus on the things that we can do before we get to that point. I often tease people and tell them, if you have to deworm your sheep or goat, you have failed them. You have failed them. That's a little dramatic, but I just want us to think of all the other things we can do so that we really do minimize the use of the anthelmintics. And I don't care whether you're organic, natural, conventional. It really doesn't matter. We'd like to be able to manage this problem and only use the drugs when we absolutely have to. Okay, some key points, though, about parasite control. Our goal is not to eradicate worms. We do not want to get rid of them. They're part of the system, and they're there for a reason. Our goal is to reduce whatever adverse effects they have on our animals, which could be death, which could be extreme sickness, or it could be production losses. We want to try to minimize those effects in practical and economical ways. Very important point. We're not trying to get rid of parasites. Second really important point is to understand that this is a very complex subject. The interaction between the parasites, their environment, which is basically the pasture, the animals, and then the various management decisions we can make, is very complex. Very complex. There's no easy answers. And part of my goal of these webinars is to try to help create an understanding for you with some ideas, but just some understanding of how things work, so that you can help you through your decision-making process of deciding what you need to do to minimize this problem, minimize this risk. The other really key point about controlling parasites nowadays, didn't exist 50 years ago, was that the worms have developed resistance to the drugs. And this is a very serious challenge to controlling parasites. And drug resistance varies tremendously by area or geographic region, by farm. Varies. I can tell you generally which drugs are least effective, but that's only looking at an area or the research done by a university. I can't tell you exactly what's going on your farm unless you were to test for it. And that's one of the things we're going to talk about next week, or what are some of the ways that you can test to see if the drugs are effective on your farm. Because when you do have an anemic or parasitized animal, you want to know you're giving it something that's going to get it better. Because I'm sure a lot of people recognize that they have a worm problem, they deworm their animals, but they still lose them because they might have given them an ineffective drug. So we need to know if the drugs work. A couple of other things to keep in mind is that, again, we don't want to get rid of worms. A parasite infection is normal in sheep and goats. So it's not a question of are they infected. Yeah, most of them are infected, and that's okay. They're supposed to be infected. Infected is probably a bad word. It has a bad connotation. If you're infected, that means you have a disease that you want to get rid of. But really, parasites aren't a disease that we necessarily want to get rid of. They're a disease or they're a situation that we want to control. And the level of infection or the amount of worms in an animal varies. Different animals have different amounts of parasites in them. Same thing with people. We have different bacteria in us. It's not all the same. So, but all the animals basically have some worms. Even if they have a negative fecal egg count, I can tell you they still probably have worms. And they have coccidia. When babies are born, obviously they don't. Not when they're born. But as they get exposed, they will have worms and coccidia. And the idea is we don't want them to have too many, especially when they're young, but we want them to be exposed. So basically, I guess what I'm saying is very rare to find an animal that's not infected with parasites. And again, I think infected is a bad word, but that's the word we choose to use. Now, the other thing that's important to remember, the nematode population, and basically, if you remember from last session, nematode's just again, the fancy word for a roundworm. We're talking about the stomach intestinal worms like the barber pole worm, like the brown stomach worm. The population is over-dispersed. It's not like there's an equal amount in every animal. A majority of the worms are in a minority of the animals. That's really important because by understanding that, we realize that we can help control the problem and improve it over time by finding the ones that are the problem and getting rid of them, finding the ones that are the good ones, and keeping them and keeping their offspring. They call it the 80-20 rule, and sometimes you'll see 70-30. But what this means is 20% of the herd is shedding 80% of the eggs. So again, if we can find that 20% and eliminate them from our herd, we're gradually, over time, going to eliminate our problem. And we're going to talk about genetic selection. That'll be the last topic for this evening. Personal opinion, that's the best way to control parasites is through genetics because it's permanent. Again, just to emphasize how complex it is. Your risk for having a parasite problem and the severity of parasite infection is going to vary by many, many things. The season. We talked about that last time. Most of the cases in the winter, in Maryland, in Connecticut, in Iowa, the parasites aren't active. They're hibernating inside of the animal waiting. But you could have a year in one of those areas where it could come, you could have problems earlier just because you have different weather. So geographic location, which is primarily climate we're talking about, has a big impact on your potential risk and severity. As I mentioned, I think in the last class, if you're in West Texas, which is very dry, that's not very conducive to parasites completing their life cycle. Not likely to have a problem. Bring those animals to the east or to the Midwest where you have the humid weather and good conditions, and they're going to have tremendous problem with parasites. Part of the reason the boar goat or goats in general tend to have more problems than sheep do when we force them to graze is because they're coming from areas, or they evolved in areas where you don't have the moisture to have the parasite problem. Problems vary by farm. I don't tend to have a big problem on my place. But I can't guarantee that those same sheep on somebody else's farm won't have some problems because we all make different decisions. We all have different resources to look at. We raise animals differently. I can tell you the old traditional system of raising sheep, we didn't have a lot of parasite problems. The ewes lambed in the wintertime. The lambs were creek fed. So we weaned in the spring, put the ewes out on pasture. The old ewe was pretty tough, pretty immune to parasites. Kept the lamb in dry lot, fattened him up. He never saw grass. He went to market. That system isn't going to create a problem with parasites. A more popular system maybe nowadays is to lamb in the springtime when the weather's nice and when the grass is growing. Well, that production system, and then keeping those lambs on their dams, that production system is more conducive to parasites. Because as we know, all decisions that we make have pros and cons. And then again, there's going to be differences in individual animals. This picture right here just shows you what can happen in a, this is our buck test from last year. This was one of our I guess our only boar goat. And you can see he doesn't have much to eat. And it was so dry and so hot, parasites were completely a non-issue. In another year, that's not necessarily the case. But because we had unusually hot and dry weather, we did not have a problem during the summer. Normally, Maryland has problems during the summer. Okay, so integrated parasite management. Looking at the whole farm or the whole system, not just looking at that animal and saying, well, I'm just going to deworm him to control parasites. If you recall that life cycle of the roundworm, we had the animal and we had the circle. We tend to focus on the animal, and we need to focus on the whole circle. How can we manage parasites instead of just relying on putting a dewormer down their throat? So what are some of the different best management practices that we can do not only to minimize the effects of the parasites, but also in turn minimize the need for deworming? And again, I don't care, whether you're organic or conventional or natural. Dewormers are expensive. We'd rather not use them. We'd rather have animals that are tough enough or genetically strong enough not to need dewormed all the time. Another good way to think of it is kind of holistic worm management. Again, looking at the whole system and all the components of the system that have an effect on internal parasites. These are the things I want to talk about. I want to focus on host immunity. I think this is one we tend to completely disregard. I think we do it with people a lot too. We use drugs to cover up everything instead of relying on these fantastic bodies that were created, the fantastic biology of the human body, of the animal body. Of course, pasture and grazing management are the cornerstone to managing parasites or to causing parasite problems. What can we do nutritionally? What kind of management decisions can we make to minimize parasites? And then lastly, I want to talk about genetics, because again, I think this is an important way that we can manage parasites, and when we make changes genetically, those changes are permanent. The last one, because it is included in integrated parasite management, is anthelmintic treatments or deworming. We're not going to talk about them tonight. That's going to be in the 4th class. It's very important, but we're not going to talk about it tonight. We're going to talk about all the other things you can do until you get to that need. And to be honest with you, I think it's almost impossible to raise sheep and goats without having to deworm some of them. And so our goal is to keep that sum as small as possible, to keep that frequency or that need as small as possible, again, regardless of what our production system is. Okay, host immunity. Sheep and goats, while we think of them as defenseless, particularly with predators, but also with diseases, they're not. They do have several mechanisms for dealing with diseases, and particularly with dealing with internal parasites. Most of us don't know much about the first two, and to be honest with you, scientists don't completely understand immune exclusion and self-cure, but they're real. And then the third one is just basically talking about immunity itself. And we'll talk about the 2 different kinds of immunity. Immune exclusion is when you have a heavily infected animal and they ingest more larvae, but it doesn't get established in them. That's not one we talk about too much, or we probably even notice, because if they're already heavily infected, they're probably already showing signs, and we're probably already going to need to deworm them. The more interesting one is the self-cure phenomenon, and we see this in our goats in our buck test. And what happens is the animal naturally expels the worms when there's this huge, massive challenge over a very short period of time. And it's usually observed after a heavy rain. I'll record like a really high egg count on a goat, but he didn't need deworm perhaps because of clinical signs. He had a good FOMACHA score, good body condition score, good DAG score, so I wouldn't have dewormed him. But then 2 weeks later, his egg count's gone down. I didn't deworm him, so that's what we call self-cure. And I don't think they fully understand it. They think it has something to do with kind of the biology of the stomach or the abomasum, the pH, something that gets created in the stomach that kind of pushes those worms out. They think it might be involved with, an immune response. They don't know exactly why. But you can have animals that have an extremely high egg count, and then it goes down and for no reason, or it goes down without anthelmintic treatment. And logically, it doesn't make sense. But it does occur, and they call that self-cure. More what we deal with is just talking about basic immunity, and that's ability to resist a particular disease. The question about an animal that is not on grass, that is not ruminating is effectively monogastric. Well, if he's not grazing, more than likely he's probably not infected with parasites, since that's the primary source. But I think, at least in abomasal worms, they still have an abomasum. So, talking about abomasal worms. And then the other worms are actually in the small intestines. So they still have those parts. But again, I don't even think they know what's happening with an adult animal. So immunity, we all have immunity, and it's just this fantastic thing. I mean, we can all be exposed to the same bugs, and not all of us are going to get sick. Not all of us get cancer. Not all of us get the flu. If you had a pandemic, not all of us would die. So there's differences in immunity, and there's basically two kinds of immunity that we need, that we deal with a disease and, of course, with parasites. The first is innate immunity, inborn, natural. The picture up there is of St. Croix, or virgin white lambs. This is the most parasite-resistant small ruminant we have in the United States. They come from the Caribbean, originally from Africa. When these lambs are exposed to parasites, they probably won't get infected, because genetically, over time, this breed has developed this natural resistance. It's part of their natural genetic makeup. So that's innate immunity. So that would be primarily what we're talking about is our resistant breeds, or even an individual that's resistant. And that's just an example with the St. Croix lambs. The Gulf Coast native is another. We'll talk a little bit about the breeds. There's certainly differences in the goat breeds as well. I don't think as many necessarily any that are as resistant as the St. Croix, but definitely there's some differences in the goat breeds. We also develop immunity. Again, a baby is born perfect. It doesn't have coccidia. It doesn't have stomach worms. The idea is that it is exposed to them a level that is adequate to develop immunity, but not to cause disease. So they have to be exposed to the disease. You have to be exposed to worms. It has to be exposed to coccidia in order to develop immunity. And really, there aren't very many, even necessarily all St. Croix sheep aren't immune. It's not complete. So all of them are going to have both innate and acquired. We're going to have more innate immunity in resistant breeds, but all of them are going to develop immunity, acquire immunity as they're exposed to disease. And immunity, of course, is going to increase as the animal gets older and as the animal is exposed to parasites. If you simply let the animal get older, let's say and it had no exposure to parasites, it is not going to develop immunity. It will get older. It needs to be exposed to parasites, to stomach worms, to coccidia, to tapeworms, to all of it. Typically, they don't start to develop immunity until they're at least 4 months old, and it will depend upon breed, actually species too, as well as the individual species of the parasite. If you were to keep deworming, you really are preventing the development of immunity. And when you deworm frequently, I always tell people that's a real false sense of security. It's a false sense of security, because if you happen to miss one or whatever, you're not letting them develop immunity, you're covering it up. So it's kind of, again, it's a false sense of security. Generally, an adult, especially sheep, but even to a large extent goats, are immune to parasites. They have been able to develop that immunity, again, with age and with exposure. I would say a 2-year-old is going to be more complete immunity than a yearling. Again, particularly with goats. But that immunity can be overcome with stress. Stress of nursing, producing a lot of milk, nursing a lot of babies, nutritional stress, pregnancy. That immunity that they have developed can break down. But generally speaking, if they're not under a lot of stress, they're pretty tough. I remember visiting some sheep dairies up in New England a number of years ago, and they were trying to be organic. And really, they didn't have a problem making the cheese organic, because those ewes are pretty tough. I mean, they're on good nutrition because they're dairy animals, and they're pretty immune to parasites. Where they had the problem was with the young stock. So the cheese was organic and the lambs were not, because they felt the need to deworm, the necessity of deworming a lot of those lambs. So adults are pretty tough, but that can break down under stress and also under a tremendous challenge, obviously. And again, let's keep in mind that goats probably over all livestock have the weakest degree of immunity. And this isn't in any way because goats are inferior. It's because they are a browser. They're not really intended to graze. If they have the opportunity to browse versus graze, they will browse. Browsing would not expose them to parasites. They are evolved from a hot, dry climate. Some of our breeds still come from a hot, dry climate. Again, the Boer goat, the Savannah goat here. So the moisture and the exposure hasn't been there. So they haven't been exposed. So voila, we put them in these moist environments of Maryland, of Connecticut, of North Carolina, and lo and behold, they have some difficulties. And then we combine that with taking a browsing animal and forcing it to graze, we have some challenges. Doesn't mean we can't raise goats here. Doesn't mean we can't graze goats, but we need to understand, but because of the behavior of the animal and its kind of evolution, that's not a natural part of them having to deal with parasites. So we've got to manage them so that their exposure is less, and we've got to find the animals that will adapt to a different climate, a different type of feeding behavior than they were originally designed for. Now, while we're talking about immunity, and we talked about how the adult is pretty resistant, she's developed some immunity, at the time of lambing and kidding, that immunity basically is compromised. It relaxes. We call this the Periparturient egg rise, which just means around parturition. It lasts for about 4 weeks. It can occur before parturition if the animals are underfed or under stress. What might be stressful besides nutrition? Weather. All of a sudden changing the groups that are together, and they have to reestablish the pecking order. That could be a stress. Dogs chasing them, that could be a stress. The thing to keep in mind about this kind of relaxed immunity, it doesn't necessarily result in making that female sick or emaciated. It may, but what is probably more important is that her egg count shoots up, and so she becomes the primary source of infection for that new crop of lambs and kids. Okay? This is kind of like when I was talking about the self-cure and the immune exclusion. They don't exactly know why this occurs. It's well documented that it occurs. It occurs in sheep. It occurs in goats. I'm not sure about llamas and alpacas. Sometimes they've not observed it in hair sheep, but generally speaking, it's a documented phenomenon that occurs. Doesn't occur in cattle. It's why I think personally organic standards should be a little bit different, because sheep and goats experience this phenomenon and other livestock do not. They think it has something to do with lactation, perhaps prolactin, perhaps a reduction in antibodies as they transfer their antibodies to their young. They don't exactly know exactly what's going on, but it is a well-documented phenomenon. And traditionally it was talked about occurring in the spring. They actually called it the spring Periparturient egg rise. So when you think about it, if it occurs in the springtime, lambing and kidding, this is a ewe that lambed in March, that lambing and kidding, especially as we push more, say, into April, it's occurring at the same time those hypobiotic or kind of hibernating L4 larvae are waking up, maturing, developing into adults, starting to suck blood and lay eggs. So you're putting those two occurrences together, and that's why it's even a bigger issue when you think about it. If you lamb back in January, the physiological part occurs, but it's not coinciding with the lambing and kidding. and those worm larvae are still in hibernation in January. So it's a far more significant problem if you're lambing and kidding in the spring, anytime through the summer, and probably continuing into the fall. So historically, the recommendation for dealing with this problem was to deworm all females prior to lambing and kidding, say 4 weeks. At the same time, you gave the CD and T vaccine. That way you wouldn't be handling them twice. I mean, you could also do it 2 weeks before, but again, you could combine it with handling them for the CD and T. And what was also important is that you use an anthelmintic or dewormer that's effective against the hypobiotic or arrested larva. Well, which ones are those? Well, the benzimidazoles, which includes Safeguard and Valbazen, if they're effective on your farm, they are effective against the hypobiotic larva. Ivermectin, Dectomax, and Cytectin are effective. Levamisole, I've read both things, that it is and it isn't. What wouldn't be effective would be the Rumetel or Strongid, which only kill adult worms and don't kill the larva. As far as the safety of anthelmintic spring pregnancy, the only one that's documented to have a problem is Valbazen. And if you read the label, it says do not use within 30 days, during the first 30 days of pregnancy or the first 30 days after you remove the ram. Okay, so if you have dates, breeding dates, dates that you remove the ram, you can follow that. If you keep the male in all the time or accidental breedings occur, you wouldn't want to use it at all during pregnancy. You would expect the same risk with goats, even though it's not approved for goats, but you would expect the same risk. Some people won't use Valbazen at all during pregnancy. I'm not aware of any other documented, proven problems with any of the other anthelmintics during pregnancy. I'm not aware of any. I favor the second two strategies. One is to increase the protein level of the ration during late pregnancy, because protein is going to help these animals make or elicit a better immune response to parasites. And then the other one is look at each animal as an individual unless your herd is gigantic. When your herds are large, you tend to deworm all the females at pregnancy. But if your herd or flock is small enough, you can look at these animals individually, decide whether she needs deworm using the FAMACHA system or the 5-point check. And again, we will talk about those decision-making tools in our next session in a week. But like I said, the traditional system, a recommendation is to deworm all females prior to parturition. And if I'm spring lambing and kidding, that's still a strategy that I may well implement. I think about it, but it's one that I may well implement if I've got resistant or a susceptible breed and that Periparturient egg rise is coinciding with the time that the hypobiotic larvae are waking up. Let's switch now to grazing and pasture management, which is really the cornerstone of effective parasite control, also the cornerstone of tremendous problems if we don't do it right. We're going to talk about each of those topics on the right. Okay, a clean or a safe pasture. And I've got a list of pastures that would qualify for that. Essentially, when we say clean or safe, we're actually saying free from parasite larvae. Free. Completely clean. And there are some instances where you might have that, particularly if you're a bigger farm where you take a hay crop or a silage crop, or you rotate, you have a different rotation for your land, or you plant some annual crops, or you graze a hay field or a pumpkin patch once a year, something like that. You can have some of these clean or safe pastures. For most of us, the idea is not so much to have one of these pastures, but to have a pasture that's cleaner and to have a pasture that's safer. This is a field from our buck test from last year. Every year we plant dwarf pearl millet, provides excellent forage during the summertime. This is going to be a clean pasture. Believe it or not, one of the challenges I have with our buck test, I don't have enough parasite exposure. I'm going to start trying to manage it, not only to try to get the goats to grow, but also to make sure we get sufficient exposure to parasites. We're actually not getting enough. I know that's not most people's problem, but for our test, where we're trying to look at differences, genetic differences in the bucks, they need to have exposure. Most of us pretty widely accept that rotating our pastures, resting our pastures, is a very important and probably the primary method for controlling parasites. What we're trying to do is create safer, cleaner, less contaminated pastures. In Europe, they tend to call it evasive grazing, because anytime there's no animals on that pasture, it is resting, and eggs are dying and larvae is dying. And the longer we rest it, the more eggs and the more larvae die. Parasite problems are driven by stocking rates, how many animals we have on a piece of land, and how long we keep those animals. Basically, overgrazing, lots of animals, lots of time, is how we tend to get parasite problems. The higher the stocking rate, the more poop, the more eggs, the more larvae, the more likely the livestock are to ingest infected worm larvae. The longer that group of animals is on that pasture, again, more poop, more eggs, more larvae, more likely they are to ingest. So the number of animals and the length of time. So obviously the fewer animals we have on a paddock and the less time they're on that paddock are going to reduce the contamination of that pasture. And people always ask me, well, how often should I rotate? And this is a hard question because, or even what's a proper stocking rate? There is no one size fits all. There's so many different variables to consider. You know, in the springtime, you can graze a lot more livestock on an acre or on a paddock than you can in the summertime, and then the fall sometimes somewhere in the middle. The animal that you're talking about grazing, dry ewes versus kid goats, all of those things are variables you have to manage. The number of paddocks that you have, the size of those paddocks, whether you do any supplemental feeding, there's just a lot of different variables. In the dairy business, in really intensive rotational grazing systems, a lot of times they move them by the half day. And two things about moving them at the half day. One, a dairy cow has very high nutritional requirements, so the more frequently you move, they tend to have a better quality feed because you're keeping it in the vegetative state. Well, a ewe or doe nursing twins or triplets is not different than a dairy cow. She has very high nutritional requirements. But the one problem a dairy farm doesn't tend to have is a parasite problem. Cows are affected by parasites, but not to the degree that sheep and goats are. And so when we move animals, there's no problem with moving animals frequently, but the more animals we put in an area, and if we don't get enough rest periods, we could actually make the problem worse with a real intensive rotational grazing system. Usually what rotational grazing is it ends up being a trade-off between, well, how can I control the parasites, but yet I also want to manage the pasture properly. Because you're not going to let a pasture sit for 3 months, particularly this time of the year, unless you cut a hay crop or mow it. And you want the animals to be eating the feed when it's in a vegetative state. So it all kind of ends up being a trade-off. And that's why I say there's no one recommendation. There are some very general recommendations that you can keep in the back of your mind. One research shows that it takes about 60 days, and this research was done in Oklahoma with goats, about 60 days for a highly contaminated pasture, meaning it has a lot of infected third-stage larvae, for that to become a lowly infected, not parasite-free, but pretty safe pasture. Takes 60 days. European research showed it took about 90 days. It's going to take longer in the spring than it is in the summer than it is the spring. A common recommendation from an agronomic standpoint has often been, well, take half the pasture and leave half. So you graze a pasture that's 8 inches, you move them when it's 4 inches. Again, that's a real ballpark recommendation. The other one is, keep in mind, overgrazing is one of the problems with parasites. And so not grazing below, say, 4 inches or 10 centimeters is a good recommendation for rotating pastures. Focusing on that 5 inches, not 5 inches, 4 inches or 10 centimeters, keep in mind that most of the infected larva is in the first 2 to 3 inches of the vegetation. Remember, parasites or the larva is going to stay where the moisture is. So they're going to stay close to the ground. So by not grazing closer than 4 inches, and that's challenging with sheep. Not a problem with goats because they're a top-down grazer. They don't like to graze close to the ground. So we can really help goats by keeping that pasture height high enough. Sheep, it seems, no matter what we do, they want their head on the ground. Now, they will eat a lot of legumes and they will eat a lot of forbs, but like a pure grass pasture, it's tough to keep their head off the ground. And again, just to emphasize, we tend to have problems because we overgraze. Too many animals, too long on a pasture. This is a real nice pasture up in Nova Scotia. They were doing a study with red clover and tall fescue, but you can see they've got some nice pasture height there. They were going to look at internal parasites kind of as a sidebar. There's other forages that we can utilize to lessen the parasite problems. Forages that contain condensed tannins, which is a bitter compound. Cattle don't like it, but goats don't mind it, sheep don't mind it. The other compound is called sesquiterpene lactones, and I'm not quite sure I've said that right, but there's a lot of plants that have that in it too. Sericea lespedeza, and chicory, bird's foot trefoil, all of the last one includes wormwood, and I think some of you have heard of that as a natural, quote, anthelmintic. They have condensed tannins. Some of them have more of the sesquiterpene lactones, particularly chicory. And there's probably a lot of other plants. We don't know, or the researchers don't always know how they work. It's not like you're deworming them with it, but these plants tend to affect, again, that life cycle. If we think of that circle and disrupting the parasite's life cycle, they seem to affect the percentage of eggs that hatch and become viable larvae. They seem to affect the development of larvae from that egg to that third stage infected larva, which is what the animal consumes to get parasitized. As far as sources for seeds, we have planted all 3 at our research center, the top 3 I should say, and didn't have any trouble locating seed. I want to talk a little bit about Sericea lespedeza because a lot of research has been done in this area, particularly in the southeastern United States. We actually failed to establish Sericea lespedeza in our environment twice. And you need to, with lespedeza, you need to make sure you get the high tannin variety. And they have developed, Auburn University has developed a variety of this. And sometimes your seed salesman would look at you really funny. Not so much with the bird's foot trefoil because that's pretty common, but chicory because that's a forb or a herb. And of course, Sericea lespedeza is actually a noxious weed in some of our states. And even if it's not a noxious weed, like someplace like Maryland, they don't like it. It's a very invasive plant. And in the Plains state, it's actually a noxious weed. So Auburn University is good. If you want to follow this question up, maybe contacting me directly. So a lot of work's been done on Sericea lespedeza. It contains high levels of condensed tannins. When they simply fed tannins to sheep and goats, it didn't seem to work. We've got a research looking at pine bark as a method, and maybe that'll turn out to be good. But basically, when we separated the condensed tannins out, they weren't effective. Sericea lespedeza is a warm season legume. It grows well in acidic soils with low fertility and is more tolerant of drought than some of the other legumes. So it's got some positive agronomic traits. In fact, probably that's why it's so invasive in certain environments. Goats will readily eat it. They say sheep will eat it, but perhaps not as regularly as goats or as eagerly as goats. It will only affect the barber pole worm, which for most of us, that's going to be our primary parasite problem. So here's a forage that has the potential to help us control barber pole worm. While the animals are grazing Sericea lespedeza, they have lower egg counts. They're less infected by parasites. Once they go back to another type of pasture, they will get reinfected. The researchers have looked at it grazing like you see in these pictures. They've also fed it as a looser ground hay, and they're also now trying to commercialize a pelleted supplement. That supplement might be more easily for small farms, more easily adopted for places where Sericea lespedeza doesn't grow as well. So a lot of research has been done into this. If you Google it, you can find a lot of information. There's a pretty good fact sheet at the Southern Consortium website. Browsing is what a goat is supposed to do. They are a browser, much like a white-tailed deer. If they have that opportunity to graze to browse and to graze taller forages like this goat here is doing, they're going to have much less parasite problems because there is no worm larva up there. The larva is, again, the first couple of inches, it's down by the moisture. If we allow goats to do what they naturally do, we will have fewer problems. Most of us don't have a farm full of browse. Maybe some of us do. But if you have any browse at all on your land, you want to manage that so that is a continuous source of feed for your goats. So it could kind of be a relief pasture or a deworming pasture, whatever you want to call it, if you can maintain some browse land. Sheep will also browse, and certainly probably the hair sheep to more degree than the conventional sheep, but they're more likely to be a weed eater, a forbs eater, which those can also be fairly high up over the ground. Sericea lespedeza is a legume. Most urinary calculi in male goats, it is possible to get calculi out of calcium, but you're far more likely to get it out of grain and get the stones made out of phosphorus because we're feeding too much grains. So grazing Sericea lespedeza I wouldn't worry about. If I was feeding males in confinement or something, I wouldn't necessarily feed them a pure legume unless I was balancing it out with something else. I just basically feed them a balanced ration. Most Sericea lespedeza is planted in pure stands. Different plants are more likely to have parasite problems. The worst thing you can graze on, and we're going to do this at my research center to make sure they get exposed, is your basic cool season grasses, fescue, orchard grass, a warm season grass, Bermuda grass. Those grasses, they're more likely to pick up the worm larva. When we can get them on non-grass plants, and here that could be a legume, it could be forb, it could be a browse, that helps us prevent parasites because the larvae don't survive, they don't stay on it, they don't migrate up it. So simply mixing our pastures so that we have legumes in them is going to help with parasites, and by God, it's certainly going to help with nutrition. Certainly going to help with nutrition. And then the alternative forages that we talked about, the ones that contain condensed tannins, just different plants that are going to be less likely to cause parasite problems. I don't think that we have near the problem when our goats graze the pearl millet. One, it's taller, the leaves are thicker, it's coarser. I don't think we have near the problems we would when we put them on the cool season grasses. Somebody mentioning about watching goats graze, they like variety. Sheep like variety, but goats like variety the most. And again, that's their natural grazing behavior. Cows are basically just volume eaters. I call them garbage eaters. They're just going to shovel all the grass in. Their nutritional requirements are the lowest, and they just go for volume. Goats need to pick specific plants, the most nutritious plants, sheep somewhere in between. Plants contain, again, the parasites are where the moisture is. In the morning, that moisture's higher because of the dew. After a rain, that moisture's higher. So if it fits your management program, you can delay grazing until the dew is lifted. You can keep them from grazing until the plants have had a chance to dry after the rainfall. Is this going to work for everyone? No. You're not necessarily going to want to have them in the barn and putting them back out. But it's another possible management strategy. And I would say particularly for a small farm, parasites need moisture. They need warmth and moisture. There's some that do better when it's cooler. They still need moisture. That's why I say West Texas, the Sahara Desert, you're not going to have parasite problems. You're going to have other problems, but you're not going to have parasite problems. Okay, most of you have heard about mixed or multi-species grazing. Most of the parasites are host-specific. Worms don't usually go from one species to another. With that said, sheep and goats are the same. They're not the same in coccidia, but they're the same in our stomach and intestinal worms. Cattle are mostly different. There's a little cross-infection with the barber pole worm and a young calf. Cows like this are perfect because there really isn't any cross-infection. Same thing with horses. Barber pole worm needs a rumen. The horse cannot or does not suffer from the barber pole worm. Okay? The other advantage, of course, is all of these animals graze differently. By using multiple species on your farm, you have animals that are going to utilize that forage differently, and you're going to get more pounds of meat or pounds of milk out of that land. You're going to get that grass more efficiently utilized. We've had a really wet spring, I think most of us. Are we having significant problems yet? We've had a wet spring, but most of us have had a cool spring. So we've had the dampness, but not the warmth. So I kind of look at it as probably haven't had much of a problem yet, but the potential is there as our weather turns warmer, because warmth and moisture is what we need. And if you happen to be a situation where you're plenty hot, then you're definitely in a situation that's going to be very conducive to parasites. Nutrition is an important aspect of managing the parasite problem, and just like grazing and pasture management, it's also can be one of the major causes of why you have a problem. Livestock are far better able to cope with parasites if their nutritional needs are being met versus those that are deficient. Protein being particularly important. The more protein in their diet, they produce more now I got to say it right, immunoglobulin. They mount a stronger immune response when they have more protein in their diet, when they have more protein reserves. It affects both the ability to resist infection, we'll talk about resistance, but also to tolerate infection. So nutrition is very key. So being especially in tune to the protein nutrition and the protein reserves that that animal has. So what are some of the strategies? Well, one of the strategies I already mentioned is feeding that ewe or doe before she lambs or kids a higher level of protein than, say, what the NRC requirements would indicate. 130% is a recommendation. Providing supplemental protein to livestock that are grazing. And I'm not saying you always would need to do this, because oftentimes if you have really high quality pasture and they're grazing it in a vegetative state, it is extremely high in protein. But there are times when it's not. One, if you're a bad manager, and I think a lot of us wish we did a better job with our pastures, I know I do. If they're grazing pasture that's gone to seed, they're not grazing in a vegetative state, not only is it not as palatable to them and they're going to eat less, but it's also lower in protein, digestible energy, and everything. During the summer, most of our cool seasons stop growing, and so the forage quality is very low, and so this would be a time to supplement protein. It will also help them utilize that poor quality forage. And then the other logical place to supplement is at what I would call at-risk animals. Like I'd be more likely to supplement animals that I early weaned, more likely to supplement ewes that are, or does that are raising triplets or even twins on pasture. So during periods in which the forage quality is poor, and also to animals that are especially at risk. We want the animals to be eating the grass when it's in a vegetative state. And a lot of people in a drought, like we had last year, they'll put hay out there for them, round bales of hay. And very often that quality of that round bales of hay is pretty poor. The hay's been harvested at a pretty mature state, and it's pretty poor. And so from a palatability standpoint, they may not eat enough, but from a nutritional standpoint, it's really not giving them that boost that they really need. Vegetative, yeah, that means before you've got seed. And with some plants like orchard grass, that really goes to seed quick in the spring. In fact, a lot of the hay that's made will have a lot of seed heads. That first cutting of orchard grass is usually pretty mature. And so it's a challenge like everything else trying to manage these plants in their vegetative state. Am I going to go over, I'm not going to go over specific supplement options, just basically talking about supplementation as a basic strategy for managing parasites with a focus on protein, because the barber poleworm in particular takes protein, and of course in general more protein means a better immune response. I'm a firm believer in having free choice minerals out there when the animals are on pasture. We want that. And talk a little bit more about goats and sheep together. If I had goats and sheep together and I was feeding sheep minerals, I would probably supplement the goats for copper, because they wouldn't be getting sufficient copper in the mineral or feed that you might be giving them. So I'd probably supplement them copper, because copper is very important to immunity. Copper is also one of the strategies that we'll talk about in the 4th week about controlling parasites. We're kind of re-looking at copper and looking at it in some different ways. Next, I want to switch to, we're running down on our hour, but I probably will end up going a little bit over, and for that I apologize. That's kind of why I can't really go into details on specific supplementation. The management options that you have, and I look at these as the decisions that you make and kind of the day-to-day management. The first one's sanitation, and that's just, you know, clean dry pens, clean surfaces, good feeders when you're feeding, clean water. When you're out on pasture, you can create situations that are worse than confinement when they congregate around a shelter, around a mineral feeder, or around water. So anytime we congregate those animals, we're creating spots that could be an increased risk for parasites. We use a grazing system in our buck test where we use a central laneway, which means they always have access to that laneway and they are frequently grazing in there. That is a potential risk site for parasites, is that laneway. Ours is big enough that we don't seem to have a real problem with them congregating, and we put the shelters on stone, so I'm not certain it's been a real risky area because, again, as I've indicated, I actually need more parasite exposure. But watch out for these sanitation problems even out on pasture. Biosecurity includes a lot of different things. When it relates to worms, I'm going to basically focus in on the idea of not bringing in drug-resistant worms to your farm. You're going to bring in worms, and guess what? That's okay because they have worms. You can't blame somebody for introducing worms to your farm. You can blame a farm for drug-resistant worms, but that is within your control. You get a new ram, you get a new buck, buy some does, quarantine that animal for 30 days. You've all heard that before. 30 days is ideal. I know sometimes it's less, but do try to quarantine it in a pen, not on pasture, away from the rest of the herd, no fence line contact. Be particularly careful if you ever buy animals from a sale barn. While you have that animal in confinement, in a pen, in quarantine, deworm it with anthelmintics or dewormers from at least 2, if not 3, of the drug chemistries. We're going to talk about the 3 groups of drugs in our last session. But there's 3 groups of drugs that are if a drug is in one family, it's very closely related. It works the same. It has the same chemistry, and if resistance develops in one, it's highly likely to develop in another member of that family. So by deworming them with 2 different chemistries, we're more likely to get those resistant worms because they may be resistant to one and not the other. I think I mentioned in last week's session, we usually deworm our bucks with Cydectin plus levamisole. That has given us a 95% reduction in the fecal egg count, which is considered a successful treatment. Last year, levamisole was off the market, and I had to use valbazen instead. We only got a 33% reduction in fecal egg count for that group of bucks. We are now going to go back to levamisole. You can use all 3 of them. You don't make a cocktail. You just give them either one after the other or 3 days in a row. You can do before and after fecal egg counts, or an after fecal egg count. This would be one situation where you might like to have 0, because that way you would be assured that you're not introducing any drug-resistant worms. If you dewormed, say, that animal with ivermectin and it killed 50% of those worms, when you release that new animal to your pasture, he is going to shed eggs that are going to never be able to be killed by ivermectin. And so that's why you want to do this. Another management option is what I call zero grazing. Like you see in this picture, they kept a lot of their dairy goats this way in China. Basically, we're talking confinement. It could be in a dirt lot or dry lot. It could be on elevated floors. It could be on brick. That's actually a pretty clean-looking farm, actually, if you ask me. You may not prefer to see goats raised in this manner, but it solves a lot of problems. When animals are in confinement and they don't have any opportunity to graze, they do not have a source of infection or reinfection. You can theoretically raise some pretty worm-free animals under this situation. Okay? Coccidiosis still tends to be a risk in confinement. And I'm not saying everybody wants to raise them in confinement, but realize that this is a potential management option for a difficult year or a difficult group of animals. Grazing is the primary source of infection for stomach worms. Coccidia they can pick up, off the dirty pen or off the dirty feeder or off the dirty water. So in confinement, to prevent coccidiosis, we still want to be dry. So if it's bedded, we want it bedded and dry. If it's a situation like this, we need it cleaned. We need it cleaned. So you're going to be cleaning up after it. And of course, obviously, we need the feeders and water is clean. This particular operation, the goats ate out of fence line feeders, so they really had no ability to contaminate the feed. The water was automatic waters, and really just needed to check those once a day to keep them clean. You don't have to be a situation like this, but you need to have the same situation where it's dry and it's clean. Parasites don't like wet. They don't like dry. Coccidia will survive. The spores of coccidia will survive a long time in dampness, and so keeping it dry and clean. I actually knew a lady that vacuumed up poop. She just had some pet goats, and it was sort of in a residential area, and she vacuumed up that poop. So I suspect she didn't have any parasite problems. She also fed the goats cookies. Okay, you can make decisions about when you lamb and kid that can either maximize or minimize your parasite problem. I don't remember if I talked about this before, and I'm cheating a little bit on the graphs, but generally speaking, if you were to lamb and kid in the winter, and that graph shows you January through December, you wean those babies early and either put them on a really good quality pasture and market them, or feed them grain and market them, and you get them gone before July 1, you're not likely to have a parasite problem, because the larva, the infection is going to increase starting in the spring. It's going to reach a peak in the summertime, and you're avoiding that peak. Okay? You can lamb or kid in the winter. Fall. If you lamb or kid in the fall, they're being born at a time when the parasite problem is diminishing. Now, I realize we have some different climates represented in our group. What happens I don't know if we had anybody in the deep south, but what happens in Louisiana is going to be quite different than what happens in Maryland and what happens in Iowa. So the graphs could change a little bit. But essentially, lambing and kidding in the fall, they're going to be born at a time where they're not really grazing. And even if they are grazing some winter annuals, the weather is still not conducive to parasites. And then they go through the winter, and you market them again during that first half of the year before parasites become a problem. So you can do that. Does it mean you want to do that? I love lambing in the spring, and I see lots of pros of lambing in the spring. So it's just another variable you have to manage on the farm. But keep in mind, besides parasites, there's some other positive advantages to these. Could relate to marketing or could relate to predator risk. But just another decision that you could make to help manage that problem. Weaning. When they've looked at the influence of weaning on worm resistance, they can't really figure it out exactly, because it's hard to separate it from nutrition. It's hard to separate early weaning from nutrition, because most people who early wean, and I'm thinking 90 days and less, tend to creep feed. So those animals are on a high plane of nutrition, and when they wean them, they keep them on that high plane. Most people who late wean tend to keep them with their dams on grass. I think what we need to realize here is, if you're in a system where you keep the lambs and the kids with their moms, or you're grazing, that's how you're choosing to feed them out, is on pasture. Keep them with their moms, because if they go out onto pasture on their own and face a substantial parasite problem, they're going to have a lot of problems. So if you early wean, you can early wean if they're on a high plane of nutrition and they're not having a real severe parasite challenge. But if they are going on grass and they're going to have some substantial challenge, don't wean them at 60 days. Keep them with their mom at least till they're 3 months, if not 4 months of age. Beyond that, there's pros and cons. I'm still in favor of weaning. A lot of folks will actually keep them on the whole time. I think once they get to be 4 months of age, I'd probably want to separate them off and put them on better quality forage and less contaminated pastures. The last thing, and I'm going to talk about tonight, are the genetic aspects of parasite control. This is actually my favorite topic. I studied breeding in graduate school. I actually looked at reproductive rate. over a 20-year period. I wasn't in graduate school for 20 years, but my data was collected over a 20-year period. And I always tell people, by gosh, it works. Selecting for twins works. So what about the genetic aspects of parasite control? That buck right there brought over $1,000, and you think, well, he's not the prettiest thing in the world. Well, really, he's actually was a pretty darn good buck. And he came off pasture, so he wasn't on a real high plane of nutrition, but he had exceptional parasite data. And that's why people were willing to pay good money for him. He came out of our buck test from 2 years ago. Some animals are going to mount a significant response to parasites. They're not going to let that parasite infection get established. This buck never ran a high egg count, never. The whole summer he was there, basically a 100-day test. His egg counts were always under 500 eggs per gram. And for the barber pole worm, that's a low egg count. Some animals are going to get infected. They're not going to they're not going to prevent infection, but they're still going to grow and they're still going to perform. Yes, he's a Kiko. So they may get infected, but they can tolerate that infection. Some of them are going to do that. This buck, I can't say he did that because I know he had low egg counts, but he also didn't suffer from infection. We will have bucks in the test that will have high egg counts, but they won't need dewormed. And then keep in mind that for these traits, and we're going to talk more in detail about these traits, there's a significant within breed difference as well as between breeds in both of these traits. I forgot to hit my clicker. The first one's what we call resistance, when we don't allow the infection. The second one is the ability to tolerate, and that's resilience. So here's the two traits. Resistance, it means I don't get infected. I don't let the worms get established. My immunity prevents it. We quantify that trait by fecal egg counts, by collecting fecals, counting eggs per gram of feces. That's how we quantify it. This is a moderately heritable trait. Heritability being the percentage of that trait that's due to genetics. If you look at the research around the world, from 0.22 to 0.63, an average of 0.25. In graduate school, I looked at reproductive rate. The average, or the heritability of reproductive rate, is 0.1, 10%. Yet most of us do select for twins. At least I hope we do, because it's proven that it works and it's going to put more money in your pocket. Well, parasite resistance, the ability to resist infection, is 25% heritable. That means we can make much more rapid progress on this than we can reproductive rate. The other trait is resilience. And again, that's the ability not to be hurt by the parasites. They might get established, but I still grow, I still produce milk, I'm still a healthy, productive animal. This one's harder to quantify. Basically, we quantify it by production. They gain better, they produce more milk. More specifically, it's the clinical signs. In terms of the barber pole worm, we could quantify it with packed cell volume, which is the volume of red blood cells. That's actually what the FOMACHA card estimates. So we do have a practical on-farm method to quantify resilience for the barber pole worm. We also look at things like DAG scores, which is the amount of basically diarrhea, evidence of diarrhea on their back end, bottle jaw, again, weight gain, body condition, things like this. Resilience is much less heritable than resistance. As a trait, it's a lot harder to get our hands on, and there's a lot less variability in that trait. Fecal egg counts, it's more objective, it's easier to get that data, and there's a great deal of variability in it. But 10% is the same as reproductive rate, so it's definitely something we can work with. A couple more things about this trait. There's a cost to parasite resistance because the nutrition that they get that has to be diverted to immunity. So there is a cost, okay, to parasite resistance. The other thing to keep in mind is having a resilient animal isn't good enough. Just because you don't have to deworm the animal, guess what? That's not enough, because maybe that animal doesn't need dewormed, but he could be carrying a significant parasite load and be contributing a significant amount of eggs to the pasture that develop into infected larvae that then infect those that aren't resilient. Are these two traits correlated? I wish I could say without a doubt that they are, but the data and the experience is not disagrees. In the New Zealand studies, the traits aren't correlated. Resistant animals aren't resilient and vice versa. In Australia, they've shown them to be correlated. In our buck test, and we have 5 years of data on that, when we started collecting enough egg counts, 1 year it was not correlated at all. 1 year the correlation was very low. So we're not seeing a strong correlation either. I'll see a high egg count, animal doesn't need dewormed. I'll see an animal that needs dewormed, and it doesn't have a high egg count. Winding down here, for those of you, I know some of you may need to go. I apologize for going over 9 o'clock. So the first way to use the concept of genetics is to start with a resistant breed. And actually, I don't call them resistant. I call them more resistant because I don't think there's any breed that's truly resistant. On the sheep side, we're talking hair sheep. Not all hair sheep, but the hair sheep that trace their heritage to the Caribbean, which then trace their heritage to North Africa, to tropical type climates. They've had that historical exposure. St. Croix or Virgin Island White is the most parasite-resistant sheep in the U.S., the Barbados Blackbelly or American Blackbelly, and then the Katahdin. The Katahdin is actually a hybrid between the St. Croix and a Suffolk sheep, so their resistance is not as good as the two, what I call pure or landrace hair sheep above them. I notice I don't put Dorper in there. Dorper comes from South Africa, much like the Boer goat. It doesn't really bring parasite resistance to its package. The Gulf Coast native, Florida native, Louisiana native, or just plain native is a medium wool sheep that comes from the southeast that had to be parasite resistant or it wasn't going to survive. If I wanted to raise wool sheep, by God, I'd go get some of those genetics of that breed because it definitely is parasite resistant. As I switch over to the goat side, again, these breeds are more resistant. No sheep are totally resistant. We've seen some difference in Kiko goats and Spanish goats and myotonic. The second two being kind of what I call mutt breeds. So they've kind of adapted to their climate. The Kiko breed comes from New Zealand where there is moisture. They bred them pretty stringently, so that might be possibly why they have some resistance. But not everybody wants to raise Kikos or Spanish, or not everybody wants to raise hair sheep or Gulf Coast native. It doesn't matter. You can select within your own breed population. But again, I want you to remember that there's two traits that may or may not be strongly correlated. Sounds breaking up, I apologize for that. So what would I do to get more resistant sheep and goats? Well, the only way I'm truly going to get it resistance is to do fecal egg counts. You can learn to do them yourself. Some labs will do them for you. A simple egg flotation that says, oh, you got a lot of eggs, won't do you a bit of good. You need eggs per gram of feces. Okay? So you'd cull them if they had high egg counts. You wouldn't select them as replacements. You wouldn't use a ram or buck with high fecal egg counts. You come to my buck test, we only sell bucks with low egg counts. Okay? You could include egg counts in a selection index. I saw one in Australia where they were using it as 20% of the index. You could select a minimum standard for egg counts. Let's say you had a group of 10 males that you were developing as potential breeders. You were letting them grow out because you wanted to see how they looked phenotypically, but you could also take egg counts. You want to do this only on pasture, and then you could look to see what they are, and you could select. You know, you don't want to ignore other traits, but you might select a minimum standard. That's what our buck test does. It selects minimum standards for parasite resistance. In the future, pretty hard to do right now, but if you lived in Australia, you could select a ram with good EPDs for parasite resistance. Same thing with New Zealand. In the United States, the only breed that they're looking at EPDs for parasite resistance is the Katahdin breed of sheep. They've also talked about the Kiko breed, but it's not really done yet. In the future, where they figure out what place on the genome controls parasite resistance, we have that to look forward to. You may be able to test the DNA of your one animal and just learn everything about it and make selection decisions. Resilience, again, is a totally different trait. Cull animals that require frequent deworming. Don't select replacements that require frequent deworming. Don't use a ram or buck that requires frequent deworming. You can get at that frequent deworming with the FOMACHA system and the 5-point check. The one thing I will caution when you're selecting your animals, and it's not just for worm resistance, it's for everything. Make sure you compare apples to apples and oranges to oranges. You must compare animals that are in the same contemporary group. That's what EPDs does. EPD stands for Expected Progeny Difference. It's a national performance record-keeping program. It's now done in Australia for American breeders. Primarily it's purebred breeders that do it because you need purebred animals really to be able to look at the genetics. An EPD tells you what this male or female is compared to the average of its breed. So if it had a 2-pound EPD for weaning weight, that means its offspring would be 2 pounds heavier than the breed average. So EPDs is another trait, or fecal egg counts is another trait that can be done at that level. But if you're not doing EPDs, you're not participating in that program, you're not sending bucks to my buck test, you can still do it. You can Google it on the internet. Somebody mentions that Langston University has a website that walks you through how to do fecal egg counts. We teach it in some of our courses. We have had strictly egg counting workshops. It's not that hard. The primary thing we do with egg counts in our buck test, we do not use them for deworming decisions. We use them to compare bucks, to look at differences in genetic resistance to parasites. But again, I just want to mention compare the same breed, this animal that's raised the same. You know, for example, let's just say you had ewes or does with twins and singles on pasture and they were 4 months old, and you took fecal egg counts from them. It wouldn't be fair to compare them because the twins would be at a disadvantage to the single. So you got to compare apples to apples, oranges to oranges. And the equipment you need to do a fecal egg count, and we will talk about fecal egg counts in the next session, is a microscope. Doesn't need to be a fancy one. You need basically, I'm trying to think, we use 400x, which is 10x on the eyepiece, and 40x on the lens, and you don't need that much. We use a singular, not a compound microscope. You need a McMaster slide, which costs about $30. You need a flotation solution, which you can make out of a saturated salt or sugar solution. And then you need little inexpensive stuff like cups and craft sticks and cheesecloth. And there's a lot of different ways to do fecal egg counts. We use a technique called the modified McMaster technique, with McMaster being the name of the slide. You can buy that slide at vetslides.com. But again, we're going to talk about this stuff next week. And that's going to conclude tonight's session. Again, we'll stay open for questions. But next week, we're going to talk about the FOMACHA system, the 5-point check, which is an expansion of the FOMACHA system to evaluate the animal for additional parasite problems besides the barber pole worm. We're going to look at the various things that you can do with fecals. Again, fecal egg counts, but also sending those fecal samples away and for various types of testing. You know, just some different things. And then again, some tests that might be on the horizon. There's a saliva test that's been developed in New Zealand. There's what I call kind of like a hemocult test, where you put a little stick in the fecal to see how much blood is in it. Kind of like, you know, when